In this video, we are going to talk about deployment and various deployment strategies that are used throughout the software domain. By definition, deployment is the process of providing a new release, a new version of your application or software to your customers. And whenever you are doing a deployment, there are certain parameters, certain attributes like cost, RTOs, downtimes, recovery times, ease of deployment, those you frame inside a strategy, and that is what is known as a deployment strategy. In software domain, there are mainly 4 deployment strategies. You do the blue-green rolling updates, Canary or toggle-based deployments, and you do the in-place deployment. Depending upon the domain in which you are working, depending upon the field in which your software, your service, your application is working, you choose either one of this. This is something that is decided by your release managers, by your system architects and your DevOps architects. So this will give you a kind of an understanding of your SLAs. So there is no one deployment strategy which is better than the other. It depends what you have committed to your customers. Based on that, you decide which deployment strategy you are going to use. In certain deployment strategies, the cost will be high, but the system will be not having any downtime. In other deployment strategies, there will be a better rollback or a disaster recovery policy in place. In some deployment strategies, the time of deployment might be very less. You might have subconscious or unconscious deployments, as we call them. And it's also possible that in your project, there will be at least 2 deployment strategies that the release managers or the architects have decided, one for the production environments and other for the non-prod and dev and QA environments, where you can have scheduled downtime windows. So it becomes important for us to understand the pros and the cons of all of the deployment strategies, and that is the precise purpose of this video. Hopefully by the end of the video, you will not only be comfortable with all the deployment strategies, you will also be able to understand and evaluate the current deployment strategy that you have in your project. So this video is not only going to be helpful for the interview candidates, but this will also give you an added advantage in understanding the release management of your current project. So let's get started. Okay, we start with the whiteboard discussion, and for every strategy we are going to go to the hands-on and then come back to the whiteboard to understand it with respect to its pros and cons. For every deployment strategy, you need to have a load balancer. If there is no load balancer, there will not be any deployment strategy, because nobody exposes their application directly to the users, all the users from different regions. What they will hit is an endpoint, and that endpoint can be a DNS endpoint, Route 53 endpoint. So basically, URL is what they will hit, and internally it will point to the load balancer. And then here, for the simplicity's sake, I have created a block and called it as app version. Internally, these is going to be something like this. There will be multiple blocks of the same version of app, v1, and this load balancer is going to target all of them based on the routing algorithm. So we are going to discuss the in-place or the big bang strategy first. Here what happens is that the application version of v1 is upgraded to the application version of v2, and the infrastructure has to remain the same, the load balancer configurations have to remain the same, and there has to be no extra cost in terms of infrastructure. So all of the users who are accessing the load balancer, the DNS, will be routed to the newer version of v2, and while doing this, there will be a scheduled downtime for 15 minutes, 20 minutes, depends upon what kind of application you are hosting. And then during that particular time only, you will be updating the version of your software directly onto the infrastructure which was hosting v1. So earlier, before the deployment, this will be v1. After the deployment, this will become v2. Now, before we discuss upon the pros and cons, let's see how this is done first. In this example, I am deploying or mimicking this deployment strategy by setting up a Docker environment. So what I will have is two services. One will be my load balancer service and one will be my application service or the container. So this guy will be one container and this guy will be another container, and before the migration this guy will be a v1 before the deployment, and then after the deployment, same configurations, same infrastructure, only one container will be updated to version v2. In my Nginx config, this is the definition. I am pointing to the container, and this container points to a service which is defined here in this compose file. And in this compose file, I do not need this section for now. Let me comment it out. So I'm going to build the project first. Again, this is going to build me two containers, one for Nginx, and that is my load balancer, and one for the application. And then there is certain logic for running the HTML page. So my build job is done, and then I will deploy it. So this has created two services, and these two services will create two infrastructure components. In this case, those two infrastructure components are containers. So if I have to draw it here, what this app1 is serving for me is one container, and this guy is also another container, and this is what I am going to replace with version v2, and I'm going to keep this as is, and we are going to see the effects by which we will be able to measure it. Let's refresh this guy, and there it goes, v1 version update of the application. And now whenever you are doing this kind of deployment, what you do is you basically test this version of v2 in your lower environments. So you will be creating this software and providing this to your QA team or to your performance and other setups where this will be certified, and you will create a kind of a backup in case of disaster, and backup will be taken when before the deployment happens. And once you have the sufficient backup, you are confident that the newer version of application is running fine, you will just go ahead and do something very similar to this. So this is the application that I have, and let me say version 2, and I save it, and I go to the terminal, or I can do it right from here. Let me stop the existing running one. So I am stopping here the existing services, because this kind of strategy does not allow you to create extra infra resources. So there will be a downtime that you have to cope up with. So you during the downtime you actually deploy the applications. So let's do that. And once the deployment is done, again for our reference, there should not be any new component created for us. You are seeing other containers, but these are with respect to Kubernetes pods. So only two containers are up, and one again is Nginx, and another one is the application. We did not change anything in the Nginx config, that is this guy here. So we are not changing anything in the logic of Nginx or in the logic of network diversion. Now if I go back to this application and I hit refresh, you will see a new version of my application is deployed. So in a nutshell, this is what Big Bang or InPlace means. You do not create new components in terms of infrastructure. You just update the application on the existing infrastructure, and the catch is that you should have a good backup created, rollback strategy should be there, and the new version of application should be tested properly. This is the legacy way of doing deployment. This is how it was done in the waterfall modules as well, and this is how it is still being done in environments where you can afford to have a downtime. This is a very cost efficient way of deploying, and if you're deploying in dev or QA environments, then this kind of deployment strategy is what you will be doing. So zero extra cost, we're not creating any new container, new infrastructure. Good for stateful application. This is an important point because your infrastructure, underlying infrastructure, is still the same. So if your applications read and write something to the file system of the underlying infrastructure, then you do not need to merge, or you don't need to migrate them to the new infrastructure, because your infrastructure still remains the same. This plays a very important role whenever your applications are stateful in nature, like a database. Downtime is needed. um, like we saw, we had to bring down the v1 version in order to get the v2 version up. Rollback is hard because you're using the same infrastructure, which means that if you have to roll back, you have to roll back from the backups, not from the existing, or there is no shadowing environment that is there which you can switch to. Then there is of course extra cost of backup because you do not have the leverage of rolling back. Then you need to take backup of your databases, your applications, and your infra code. Deployment time is moderate. Now this deployment time, it will be clear to you when we talk about other strategies where the deployment time is high. But what it means is when the moment that you start the deployment and the moment that you end the deployment, what is the duration of that entire thing? So it is moderate. It's not that you are within the fraction of a minute or unconsciously deploying something. Here you will have to have a certain downtime, and during that downtime you will have this deployment time also extended, but comparatively relative to other strategies, it's still moderate. And then there is no version compatibility concern. Again, this is something that will be clear when we talk about other deployment strategies, but just let me explain it in a high level. This app will not be one monolithic application. There will be hundreds of microservices that are combined together, and they form together this application, right? Some will be having the login logic, some will be having the authentication checks, or some would be having the caching logic, other might be having some business logic, UI logic. All of them together combine and make this application. Whenever you update this kind of deployment, you are more or less updating everything or all the microservices that are part of this entire application. Although you can selectively update only few of them, but you will never have a situation where you would have to uncover versioning issues. So your compatibilities will be checked in other environments, and you don't have to worry or create any new strategy for that. So the next strategy for us is called blue-green strategy. And blue-green strategy and Canary strategy are a little bit similar in terms of the infrastructure that you create for them, but they are different when you talk about targeting specific users. So here in blue-green strategy, what you have is you have an extra infrastructure that is created. Your v1 will be running, and you will create a v2 in an environment which is very much similar to v1. So you will have an identical infrastructure created, and that infrastructure will mimic the infrastructure of v1, and in your load balancer you will have routing logics to both of the versions. You do not want your customers to directly use the v2 version. So what you do is that they will still continue to work on v1, and your QA teams and other teams will mostly they are going to be beta users and non-functional and functional testers who will continue to test this version of your application. And then when everything looks good, everything looks fine, what you do is in your load balancer you kill this connection and you only keep this connection. And for the end user, they will never know that there was a switch, and there is no downtime also in this deployment strategy. So let's see how that happens. I will have two services in place of one. I've given it as weightage is equal to 5. That means equal weightage, but this is not important. What is important is that your load balancer is delivering the deployment strategy for you. That's why I said without load balancer you will not be able to achieve any of the modern day deployment strategies. And what happens here is you will be having two versions of your application running. So in this case I will be having app 1, which is already present here, and then a new container will come up in the form of app 2. That's going to be this guy here. And depending upon the intelligence built in my load balancer, I will be able to drive the traffic, selected traffic, to either v1 or v2. I can totally cut the connection in the load balancer config files whenever I have to. So the switch is pretty straightforward and fast. 3 containers that are getting started. This is version 1 of the application, and this is being served by this service here, which is running on port 5001. And I can also check that by doing this. Of course, you can hide it. I'm just showing it for this demo purpose. And then the same load balancer will also be serving me the other version of the applications. So biggest advantage for this is that there is a zero downtime and the rollbacks are pretty easy. Mission critical systems generally have this kind of deployment strategy, but you have to remember that there is an extra cost associated with it, and it is also not good for stateful applications, because as you can imagine, with the new infrastructure, the file system of, if your application is writing something to the file system here, then they have to be detached and reattached to here. There is no extra cost on backup because you are always relying on the rollbacks. Deployment time frame is very high. It's high because for a DevOps engineer, the deployment time frame starts whenever you start creating this new infrastructure. So you have to not only create it, but you have to even test it. So there is an extra effort there as well. You are supposed to test here network connectivities and file system compatibilities and the legacy checks. And again, like in the InPlace, there is no version compatibility concern here because you are already deploying something which is well tested. Whenever you go with version v2, the set of services will be in one specific version. Okay, so the next one is called toggle strategy or Canary strategy. Here what happens is, very interestingly, you can choose, let's say this guy is from US, then you can decide that this guy can be served this version of the application. Another one, say this guy is from UK, and you can decide that this guy will be served the latest version of the application. And then if somebody is from Asia, they are served the default version of the application, that is this guy. So here again, load balancer plays a very important role because all of this logic of routing the traffic is going to be handled by your load balancer. Now there are various versions of, or various flavors I should say, for this kind of deployment. Sometimes people also release a new beta version of their application and provide it to the testers all around the world, or to the common people who are outside of their network, and ask them to test it. This is the kind of strategy that is applied there as well. Or there can be a new feature that has to be tested, and it has to be tested in such a way that the actual application does not have the load of it, and that's also one key point with this strategy. So in this case, what I have is two locations, location US and location UK. You can create any kind of intelligent logic within your load balancer. Whenever there is a user which is coming from US, I'm going to route it to the older version. For the UK, I'm going to route it to the newer version. If there is a user which is not from US or UK, what I'm going to do is I'm going to route it to the default version. Let me save this, and let's save this as well and rerun the build job. All right, so let's go back to the terminal and we say 8080, and we get the default version, but also you see that it is going to the 501. Now we can hide this, and I'm keeping it explicitly open so that you understand. For default, it is going to the older existing version. The users from UK, then they should go to this guy here, the newer version. And you see they are routed towards the newer version. So version v2 can be provided to only users who are from specific region or beta users, and version v1 will continue to work for the users that are the regular users. So the organizations that take security seriously and they which do not have the bandwidth of having a downtime, this is the preferred way of deployment, what they do. So if I am a bank, or if I am in a security domain or in airlines domain, and I want to see that how the newer version of my application is going to be, and I want to test it somewhere, but not having the grudge of it on my actual application, and I also want it to be tested by my internal test teams, then this is the kind of so this guy red you can mimic as a customer, and the customer is directly testing the newer version of the application, and when they are satisfied, what they'll say is, okay, cut down this connection or keep it as long as you want, but I don't care because I'm being served with the newer version of the application, or the version of the application that I desire. So you can have targeted feature given, or targeted version given with this kind of strategy. Again, it is not good for stateful application, obviously, because if there is again dependency on the file systems, then that dependency has to be carried to the new infrastructure, because you will create a new infrastructure. No downtime is needed because again it's a load balancer switch. Rollback is easy and fast because at any given point in time you have two connections. No extra cost of backup because again same reasons. Deployment time frame is high. Again, as in blue-green, we were creating a new infrastructure. So as a DevOps engineer, this is your starting time and this is your end time, and this is your time frame. So the time frame of release becomes big. So all the companies like Netflix and Amazon Prime, who do unconscious deployment, or who are very confident in doing regular deployment, do not go with this strategy because they want deployment to happen every day. And here this is more like how Apple releases its products. They provide it to beta users, and then when the beta users are done with raising bugs and testing, then the same version is applied to all of the other users, and hence you see only maybe 1 or 2 OS releases that they do in a year. So this is also good for testing performance, and version compatibility concerns are not here, and selective release can be done. This is the key feature. In fact, these two are the key features that control over traffic. You know that X is coming from one region or one zone, and I am going to route my traffic in such a way that they go to a specific version of my application. This is a key selling point for this strategy, and also the selective release feature. All right, the last one and the most famous one, again this comes in multiple flavors, and it's called rolling strategy, because you rollingly update your applications. Now, like I said before, at no point in time you will only have one infrastructure serving the application. You will have multiple. In this case, V1 has 3 replicas, 3 instances, and internally these again can be tens of microservices, right? So this guy is hosting 10 of microservice, this guy is hosting again 10 of microservices, this guy is hosting again same number of microservices, and they are actually the replicas, mirror images of each other. Now in rolling update, what happens is that you define a strategy where you say that do not touch any of these existing ones, just bring up the new one. So bring up another version which is like a V2 version, and when that V2 version is up and ready, you route this load balancer to also include that as your target, and then you take this guy down. Or you can actually, if you want to save cost, what you can do is you can bring this guy down beforehand and then create this V2 version. It depends on max surge, that's the field, and we are going to see that in the hands-on. So there are a couple of flavors to this. One is if you do not worry that much about the cost, but you worry about the downtime and you don't want to throttle your CPUs and you don't want to have a lag in your website, then what you will do is you will create extra infrastructure to host these V2 guys, and only when these guys are up and running, then you will bring out or bring down the V1 guys. So for the first run, this guy goes here and this guy goes down, then this guy is serving. For the second run or second container or pod, however you have it, you will have V2, and when this guy comes up, this guy goes down. So you are sequentially updating, and again the traffic to this guy goes here, and this traffic is closed, this traffic is closed, and eventually these two also replace places. This guy goes down, and this guy routes the traffic here. This is a very long process of deployment, because imagine that you have and this is very common, right? You have at least 4 replicas of your infrastructure, and you have hundreds or thousands of microservices, very common in big scale organization. So you are actually updating all of these microservices one by one or percentage wise. Hence, the time frame in which you are going to do this deployment increases significantly. Also, there is a catch. Whenever you are doing this kind of update, you do not have a control over traffic. At no given point in time will I be able to decide whether v1 will be serving or v2 will be serving, because some of the pods will be in v1, some of them will be in v2. I've been told that this can be managed, but I'm yet to find out how that is managed. To me, it just becomes difficult to manage the control over which version of my application should be shown. And this is also one of the main drawbacks of rolling strategy, because imagine that there is a security bug or there is a big loophole in your application and you want that to be down immediately, and you have an infrastructure like this where you have thousands of microservices, thousands of replicas of the same service, then you will, even though you have started your deployment, but your existing application version might still be up and still be open to vulnerabilities. So keep in mind when you're doing rolling strategy, that is the biggest loophole. One, it takes ample amount of time, and second, you do not have the control over traffic, and you also have version compatibility concerns. Now what that means is, if I have v1 and v1 is made out of say these many microservices, and all of them are going to be updated, so when the update starts, some of the pods might be in the latest version, some of them will be in the older version. So this guy might be all in latest version, this guy might be some in latest version, some in old versions. Again, that is applicable to others as well. And then if your application microservices are not backward compatible with one another, then you are going to be in trouble, because there is no traffic control, and you cannot decide that which version of my microservice should be talking to which version of the other microservice. That's again a black concern. The extra cost on backup, yes, there is a little bit extra cost, but not that much. The biggest advantage is that it's an instant feedback. What that means is, when you start this process and you just go ahead with one deployment, say for example this deployment I'm doing, all the three are already running. If this guy comes up and this guy fails to start, it will not have any effect on the other pods and other applications, other instances. The others will just keep working as they were, and only this guy will be failing. So I'll get an instant feedback, and I'll also get an extra time to fix it, because there is no problem with the current version of the application. Okay, so let's see how that is done. I can do this with Docker Compose, but I prefer to do it with Kubernetes. It's simpler to explain there, and also you have a lot of features in Kubernetes which are specific to this kind of a deployment strategy. So here is my code. I have a deployment YAML. My deployment YAML has 3 replicas. That is these guys here, v1, v1, v1. There are 3. So all 3 of them will be changed, and I have said max unavailable is equal to 0. That means that you start a v2. I don't care about the budget, I have the money. You start v2, but don't bring down v1 till v2 is up and running. The max surge is 1. You can also give this in terms of percentile, so you don't have to give 1 and 2. You can say max surge is 25%. What that means is, if I have 4 pods of v1 running here, and I say that, or let's say I have somewhere around 100 v1 running, and I say 25% is the max surge. So that means that only 75% of, or the only 75 pods have to be running, and you can do this deployment for the rest 25. This becomes very important because, like I said earlier, there will be thousands of pods in actual production environment. You cannot do one by one, so you go by percentile. So I have a service object, I have a deployment object, and I am good to go. So all of my container pods are running with a specific version of the application. Let's open another terminal which we can continuously watch, and you're seeing that there is app1 version v2 is running. Let's revert it to v1 and see how that happens. So we go back to this guy, and let me make the changes in the file system. Deployment v1 I want, v2 is running. I say I want v1. Okay, cool. Apply it again, and let's go back to the watch. So you see that there is a new pod that is coming up with version 1, and it is not touching anything in the existing deployments or existing pods. And this is very important because I am okay with spending more infrastructure, but I do not want the existing services of my application to have any throttling effect. And you will see slowly new pods will keep coming, and the older ones will only go when the newer ones will be ready and their probes are certified and they are up and running. But the problem here is that now I have v1 version running, but it's up to load balancer to decide which pod it is going to serve to on this node pod. I cannot control that, and that's when I said that it can be a problem if you have a bug running in your existing code and you want the rollout to happen immediately. But this is the kind of deployment that happens subconsciously, or this is the kind of deployments that lot of video streaming applications, a lot of video streaming websites do, because this is easy to automate and is also tolerant to fault. I'll show you how. Okay, eventually we will only get the one version of the app, and that's when all of the existing version will phase out. Now let's imagine that there was a defect in my deployment, or there is an image which is having a problem, and I'm trying to deploy this guy. Now I'm giving it a new version and I'm saying that go ahead and deploy, and this one doesn't exist. So in my deployment, I am saying that you replace all of the existing versions of the application, that is all of these guys you replace with v3, but v3 is either buggy or doesn't exist. Now in this kind of deployment, what happens is that in the other deployments, if I had done this kind of a problem in my deployment manifest, that would have an effect in one way or the other. Here it will not have any effect, because what it is doing is it's creating another pod altogether, and the existing ones are not even bothered. So let's run this guy, and then you go to the watch and you will see that there is one more guy which is scheduled. This is version v3, and very soon you will see that there will be a defect, or there will be a instant feedback that I will get from the strategy saying that this guy has failed, and we are not touching the other running ones until you fix it. That's its biggest advantage. If I go here and I say you see that this guy has failed, which was version v3, but the others are not affected, and the load balancer is not going to give any traffic to this guy. So you can have this kind of deployment strategies planned whenever you are doing an automated deployment, or whenever you see people doing Argo CD based, Helm based, Flux CD based deployments. This is the most common strategy that is applied. All right, that's all for this one, and these points that we were highlighting with respect to all of the strategies, these are actually discussed in your SLAs. These are the points when you talk to your customer, you describe to them that we will not have downtimes, or our rollbacks will be this faster, this is the frequency of our deployments. These are actually the points that are part of your service level agreement with your customer and with your client. So do remember to check with your manager or with your architect what is the SLA that you have, and then evaluate which kind of strategies that you are using, and whether or not they are matching these parameters. Okay, that is all that I had to discuss in this video. Hope you found it informative, and if you did, then do share it with your network, and I'll see you in the next one.